The human colonization of Mars has been a popular concept in science fiction for decades. However, in recent years, the prospect of transporting humans to Mars has grown quite serious. People could be sent to Mars in the near future, thanks to the efforts of numerous private enterprises and government agencies. But what technology is required to make that happen? In this video, we'll look at some of the parallels between our planetary neighbor and Earth, as well as some of the technology that will allow people to live on Mars. Earth and Mars are solar system neighbors, sharing certain characteristics such as rocky composition but varying in others, such as size and temperature. Although the same minerals make up Earth and Mars, their proportions differ. The two planets are also assumed to have originated around the same time, in somewhat different ways. While many forms of life exist on Earth, it is unknown whether any exist on Mars. Let's look at some of the similarities between Mars and Earth. Similarities between Mars and Earth. According to the European Space Agency, both Earth and Mars are thought to have formed roughly 4.6 billion years ago from a vast cloud of hot gases surrounding the Sun. Since then, both planets have gradually cooled and solidified into the spherical shapes we observe today. Both planets have strong outer crusts and dense cores. Interestingly, water played a role in both of their histories. Size of the planets. According to the Center for Mars Exploration, Mars is about twice the size of the Moon and slightly larger than half the size of Earth. Mars has a diameter of approximately 4,217 miles, which is a lot smaller than Earth, which has a diameter of around 7,926 miles. With these numbers, Earth also has a mass that is 10 times bigger than its sister planet. This difference in size and mass caused Mars to cool much faster than Earth after its original formation. Its greatly reduced gravity also resulted in a faster loss of volatile elements like water and gases. Atmosphere and water. Mars has an extremely thin atmosphere composed primarily of carbon dioxide. The average atmospheric pressure is 7 millibars compared to Earth's 1013 millibars. Mars has substantially colder temperatures because it lacks an atmosphere to insulate it from heat loss. According to NASA questions, the average temperature in the mid-latitudes is minus 50 degrees Fahrenheit. It can get down to minus 76 degrees Fahrenheit at night, with daytime highs reaching 32 degrees Fahrenheit or 0 degrees Celsius on the thermometer. Although water may have once existed on Mars' surface, it vanished long ago for mysterious reasons. In reference, the Earth's surface is made up of 2/3 water. However, there is a theory that most of the water on Mars might be locked up under the surface. This could mean our planets are more similar than any of us suspected. The outer crust of the Earth is constantly moving. It is separated into huge plates that move from side to side. In contrast, Mars's is steady, but there appears to be some subsurface magma activity. As a result, its geologic state varies wildly from that of Earth. Greater stability on Mars preserves more of its ancient features, some of which date back 4 billion years. What is it like moving to Mars? The first step is to be able to reach Mars. The typical distance between Earth and Mars is about 140 million miles, and as of right now, the journey takes between 6 and 8 months. Transport to Mars would have to accommodate a small to a medium number of people for that duration, as well as the time they would spend on Mars and the return journey. The longer the trip, the more expensive, demanding, and risky it is. Their fuel, life support systems, and food must all last for this length of time. So in order to shorten the journey, NASA is developing more efficient propulsion systems that use nuclear thermal propulsion. Nuclear thermal propulsion is more than twice as efficient as present technology. The operation is simple. A nuclear reactor heats up a propellant such as liquid hydrogen. As the hydrogen is turned into gas, it gives thrust to the spaceship through a nozzle, propelling it forward. The landing will be indirectly challenging if we want to start living on Mars, because a spacecraft will have to be quite massive to support a lot of people on the journey to Mars. This is extremely significant given the differences between the Martian and Earth atmosphere. Because its atmosphere is thinner, a spaceship will descend much quicker than on Earth, and traditional technologies such as parachutes will not be effective in slowing the descent. The best option is to use heat shields. These are stiff metal structures that absorb the majority of the heat upon re-entry into an atmosphere. Because of the great speed, the friction causes enormous heat to build up in the front of the spaceship. A heat shield deflects heat away from the spacecraft while also protecting the underlying spacecraft. Right now, this type of heat shield is simply too large for a spaceship of the size required for human transit to Mars. Inflatable heat shields can help in this situation. An inflatable heat barrier, such as the one being developed by NASA, could significantly improve this process. Protection from the Martian atmosphere. Currently, the Martian environment is hostile to human beings. There have been numerous approaches to this challenge in science fiction. But how would it appear in real life? The Martian atmosphere is thinner and colder, with over 95% carbon dioxide and only 0.13% oxygen. There are also significantly higher levels of radiation. This means that humans will have to live in self-sustaining environments. To begin, the habitats must be capable of producing and recycling the proper amounts of gases for humans to breathe. The major method proposed is to recycle the nitrogen and argon present in the Martian atmosphere to add oxygen to it. For this particular approach, 40% nitrogen, 40% argon, and 20% oxygen could be used. However, in order to remove these gases from the environment, carbon dioxide must be removed from the air. Furthermore, oxygen must be generated by extracting it from existing water on Mars or transporting it from Earth. Finally, with increased solar radiation on Mars, Martian residents will require some form of radiation protection. The first option would be a radiation shield, but this is very heavy and difficult to transfer from Earth to Mars. Another option could be living underground in Martian caverns or lava tubes. For this reason, an inflatable doorway is being created that can offer an airtight segment of the subsurface networks. Staying warm and keeping fit. Mars has an average temperature of -80 degrees Fahrenheit or -62.2 degrees Celsius. Temperatures can also vary dramatically. While it may be -100 degrees Fahrenheit at night, it may reach as high as 70 degrees during the day. This means that one of the key issues of a Martian habitat will be temperature management. Mars's gravity is relatively mild. It's approximately 38% that of Earth. Because of the lower gravity, people on Mars are more likely to lose bone density, which increases the likelihood of fractures. This does not include the months spent in zero gravity on the journey to Mars. Astronauts must exercise on a regular basis in order to survive long periods in microgravity. NASA is investigating spacesuits with increased resistance to counteract this. Meanwhile, astronauts from the United States and Russia are conducting year-long experiments aboard the space station to better understand the consequences of decreased gravity on the human body and if we can adapt. Production of water, food, and fuel. Water does exist on Mars, however, it's mostly saline. This indicates that desalination will be required to make drinking water safe. In theory, all water would be recycled because it's more energy efficient than collecting and desalinating more water. But what about plants though? Could we find the right plants we need to survive for a long time? The surface of Mars contains all of the elements required for plant cultivation. It contains water and chemical compounds that plants require for survival. However, Mars lacks a welcoming environment. Greenhouses that efficiently produce a plant-suitable atmosphere will be a primary goal, as this will be the only way for Mars to generate food. Everything we've discussed so far demands fuel to produce energy. The most likely technique of fuel production will be to reuse the water that is currently on Mars. Water may be broken down into hydrogen and oxygen. Oxygen may be used to create a hospitable environment, while hydrogen would be repurposed as a powerful propellant. So, before deploying humans, an automated hydrogen processing factory will need to be built to assure that fuel is available. So, can humans live on Mars? Yes, but not without difficulty. There are major roadblocks in the path. The key problems are getting to and from Mars, enduring the hostile environment, and manufacturing food, water, and fuel. Despite the fact that this appears insurmountable, scientists are optimistic. Elon Musk, for example, has suggested that SpaceX may transport astronauts to Mars as early as 2024. And while the initial few trips will most likely only involve a brief stay on Mars, it's still a great achievement. What do you think? Would it be possible for humans to live on Mars? Let us know your thoughts in the comments.